which concerns, so we're going to be speaking today about test case design and specifically the ways in which we can sharpen the design of test cases with particular lines of reasoning and artful selection, skilled selection of test cases. To that end, I had actually asked you to watch 2 videos for this time, for this class. Those videos include discussion of orthogonal array testing. They also include discussion of some basics of coverage testing. And I'll see if we can weave in some components of that. But I wanted to provide some additional heuristics as well. So we talked about the V model of testing a lot in this class. A key need, regardless of the level of testing one is exploring, there's often key needs that play out on designing test cases. So whether you're performing manual gherkin-based tests or whether you're performing tests through, a common testing framework like through JEST or through, an older framework like JUnit or JSUnit, you need to put some thought into test cases, particular situations that will be tested in individual tests, whether they're manual, automated, whether they go through the UI or programmatic. Generally, you formulate test cases. The exception is exploratory testing. Exploratory testing is kind of adaptive testing where you kind of follow your nose and maybe you have an idea of where to start, but a lot of it is kind of learning along the way and you adapt as you sense instability or sense slow response, etc. Exploratory testing is good. Often you can do some fruitful exploratory testing, but a lot of the real value with testing comes from systematic creation or addressing of test cases. And I'm going to that end, talk today to supplement the videos I asked you to watch on creation of test cases, and indeed the exercise I asked you to pursue. Okay, so within this sphere, there's many approaches, heuristics, design principles that we can use to arrive at thoughtful test cases. A key reflection here is, look, almost never can you exhaustively test a system. By exhaustively, I mean run every possible test case. Time is limited. Your time, often, being the key limit. Sometimes it's computation time, if you think about UI tests, right? And when resources are limited, in general, we have to ask, where can we get the biggest bang for the buck? Where can we get the biggest gain from the least investment of time? For a given investment of time, where can we get the most gain? And the techniques I'll be talking about today, whether it's use of reasoning about equivalence classes and boundary values, whether it's talking about orthogonal arrays, well, the brief glimpse of decision trees and tables. A lot of those are about creating test cases that are thoughtful and more likely than just randomly created ones to find defects. They're more likely to stumble on a defect than if you just played around with random tests. Random testing has its role. It can be especially effective in stress-based testing and load testing, but also in just trying push a system that might have race conditions, et cetera. And exploratory testing is valuable too, to conduct that alongside regular case-based testing. But creation of test cases is a science and an art that can really pay off, because you put your effort into testing that really matters, to test cases that are more likely, a lot more likely than a chance than show a problem. The idea behind equivalence classes is very simple. When you're designing systems, whether it's the high-level UI for a system, here for getting airline reservations, associated with airline reservations, getting particular seats on a cabin, or whether it's designing of test cases for a particular function at the sort of lower level. Often that bit of functionality, the UI interface with reserving seats, or the function, how it handles parameter values, it exhibits behavior that falls into a couple different types. Maybe there are different, there's a correct type of behavior of a couple different sorts based on the types of input. It behaves in somewhat different ways. The behavior falls into certain categories, how it handles inputs. And then for how it handles incorrect inputs, which is of great interest. We want a system that's often robust, given inputs that are not legit, but it should detect. Those fall into a couple types, right? And so if we were dealing with reserving seats, for example, on a commercial airliner, we might classify seats. If we're testing the system through its UI, we don't just randomly plug in seat numbers and see if it seems to work okay for reserving that seat. Often it'll be better off to be more judicious, and you'll choose seats that are kind of representative of different equivalence classes, these clusters of cases which are handled in the same or very similar way. So for example, you may have a business class or first class cabin, and then a coach class within it. And then within a given aisle, anyone want to say, what sort of seats do you have? What are three major seat types that you might have for the coach class here? Well, okay, so maybe economy would be going with the coach. But even within economy, what are three types of seats? Window seat, aisle, and middle, right? And look, to pass the red face test, to say that you thoroughly tested this, per Trushank's comment, like you'd want to test it with at least one seat in economy and at least one seat in first class, no question, right? I mean, if you haven't tested it with a premier seat, whether it's business class or first class, whatever, and with economy, like you don't know whether it's going to behave properly with that class of seat. But beyond that, you'd want to test that it's working properly with an aisle seat, a window, and that it knows about middle seats for the aisles that have them. You notice in the first class cabin here, there's no middle seats. And you want to make sure that it knows which aisles have, so which sort of seat number aisles have middle seats versus don't have middle seats, right? So here you might have a breakdown of two types: first class cabin, right? First class cabin, aisle and window, and then for the economy class or coach class, you may have aisle, middle, and window. But then you might have, anyone else want to mention a further class you might have in a contemporary airliner? Yeah. Mm, mm. That's an interesting one. I mean, there are sometimes special seats used in the back, and actually okay, I'm not going to get into it. The staff will often go up in larger airlines for long haul flights. You'll have the staff actually go up a little staircase and they'll sleep upstairs in a little sort of cubby hole above the back of the plane, but those aren't reservable seats. You can't go there and like conk out for the 18-hour flight to Sydney, Australia from Vancouver. And there are, of course, seats up there for the pilot, but those are not reservable. But there's another class of seats. It's kind of indicated here. Yes. Yes. Yeah, the emergency exit seats, the bulkhead seats, and that's where they are. And they have a bit of extra legroom, but they don't have like the space to put things under the seat in front of you. You have to put them overhead, but they can have different costs associated with them. And there can be restrictions on who can book them, like a passenger who's known to have physical restrictions, like needs wheelchair assistance. They wouldn't be able to occupy an emergency row seat, but they might be restricted to other classes of seats too. So it's a bit subtle, but the point is these seats, it's not that you go through and test every possible seat here in the entire coach class. To at least have face plausibility, you're going to test seats of at least one example, one representative of an equivalence class, like a first class aisle, a first class window, a coach class aisle, coach class window, coach class middle seat, not those collectively, not in an exit row, and then in an exit row, maybe middle aisle window. Mm-hmm. And that there you could pass the red face test. At least you've tested, a reasonably thoughtful set. And the idea here is, look, if there's a problem with its middle seat, algorithm, whether you're reserving middle seat in aisle 30 or middle seat in aisle 10 or aisle, 23, probably is likely to be immaterial. It's probably a type of problem that will occur for middle seats in general. That it might not be able to understand the middle seat configuration for seats. So you don't have to test exhaustively, but you want to test thoughtfully. Does this make sense? And you want to at least not leave out broad classes of seats, like bulkhead seats, like exit row seats, like Jason said. If you don't test those, you can't be said to have tested thoroughly. And of course, in general, you want to try to test it with invalid seats, like seats which the user might be able to select through the interface, but which are not valid. Maybe it marks it as not available, for example, on this flight. Or marks it as already reserved, and they try to reserve it anyway, and you want to provide a feedback for that. Or maybe it's a passenger who's a child, and therefore is not allowed to be seated in the exit row seat. And so you want to try to make sure that it correctly handles that incorrect user request. Jason, you had your hand up. Yeah.
Did you have test cases or things that should detect that it failed?
Yeah. So thank you for that question. We will come back to that and to this point probably in our session in arts. But you want to take a clear stance to that with respect to any given test scenario. And I want to highlight that different software development teams will have different attitudes with respect to this, particularly with respect to assertions that handle errors from other areas of the code base. One attitude is, look, these are documented as part of the, say, preconditions, postconditions, if they're documented as part of the preconditions, postconditions, and someone doesn't adhere to them, we want to discover it as soon as possible, and we want to root it out in the testing phase before delivery, before it goes into production. but the assertions won't be there in production, so it's not an error handling strategy. A different attitude, though, is, in general, I think most people would agree, putting the effort in to handle them robustly, like to actually turn them into meaningful error messages and log them and indicate them, that's better yet than assertions. Does it take extra effort? It does generally. And what you don't want to do is to make great, as they say, the enemy of good. You don't want to say, well, assertions aren't good enough to us, but I don't have time to handle it as errors, right? Like, look, that's great if you want to handle it as errors, but if you don't have time or you feel the risk is too low, etc., if it runs contrary to your sort of philosophy of what teams should take responsibility for what errors, at least put in an assertion. Assertion, though, is, I'd say, not as favorable in my view as handling. Now, if you have an exercise like I gave you for today, which we'll be talking about, I have a slide on it later. For that exercise, you will want to take a stance like, I'm assuming that this function should handle as errors illegal values, and I want to test it on those. Or you say, look, anything that's a precondition, I forswear violating that precondition because I know that it's ruled it out. So I'm going to confine my tests to things that are legitimate according to its preconditions, and we'll be testing whether it meets its postconditions. You need to take one of those stances. Either fair game to violate preconditions because we want to see if it correctly handles them as errors, or we live within the preconditions and we'll test it within those bounds. You want to be clear about that. You want to be clear for the final exam. You heard it here first. Okay, so yeah, a square root function. What are some equivalence classes for a square root function? What are some values you might try it with? Like, okay, so you have a routine that takes a double precision value and it returns a double precision value, and it's the goal is for it to operate with positive or non-negative values. So what are some values you might give a square root that would help you develop confidence it's working properly? Okay, 64. Why 64? It's a square of 8. It's a square of 8. So it's a perfect square. Right? Do we have to test it with every perfect square? No, but at least we want to test it with one, right? I mean, that would be pretty indicative, right? That will help. It might expose a certain type of error because it probably will behave on a lot of those pretty similarly. Jason has hand up, yeah? 0 is an excellent one. Okay, so you'd want to make sure it handles negative numbers robustly. Good, I like that. How about another one? Prime numbers. That's an interesting one. Yeah, prime number is never going to be a perfect square. That's clear. And yeah, I mean, a prime number might be a decent one to give it. There might be some number theoretic reason for why those might be kind of similar to one another. Often we're looking either for singular numbers, like numbers that are distinctive, and there's another one besides 0, I might add. But then there's going to be some that fall into classes. And the question is, does it exhibit certain behavior within that class where testing it at one kind of tells you how it will behave when testing it the others? Like a perfect square is probably a good example of that. If it works really well on 64, it's going to probably work pretty well on 9 and work pretty well on 81, et cetera. But Jason, you had your hand up. Mm.
Something like something where
Mhm. Yeah.
like
Mhm. Underflow and overflow. Yeah. Right. Excellent. Yep. Yep. Yeah. Right. That's right. So yeah, you're talking about explicitly reasoning out like the IEEE standard for floating point representation and choosing numbers that are such that there's inevitable rounding, for example, in the results, et cetera. And that's a very good idea. And that's a very savvy strategy that might illuminate sort of whole classes of numbers. So I really like that. How about another number for square root beyond 0 that is very special? It's the fixed point of square root besides 0. 0 is a fixed point. What's another one? No, it's a very common number. Yes, Aladdin. 1, right? 1 squared is 1. 0 squared is 0, right? Any other ideas for like special numbers? You could test the double limit, the max double, or you could test min double would be negative, but you could do that. You certainly want to test some negative, right? And make sure it goes up. And so the point is, you don't test it against all doubles. No. You're artful. And the thought is, look, if you test one of these like a perfect square, you're likely to get a sense how it behaves with others. I mean, to be sensible. Negative numbers, another good example, right? And some are kind of unique numbers like 0 or 1. We'll come back to them with boundary value problems. Those are good. I would say between 0 and 1, they have the property that if you take the square root, how does the square root of numbers between 0 and 1 compared to, it's bigger than the number of which you took the square root, right? Right? If you take square root of 0.25, you get what? You get 0.5. Yeah, it's bigger than 0.25. Or if you take the square root of things greater than 1, the square root is always less than that number, right? The square root of it is always less than it, right? Square root of 9 is 3, right? Smaller than 9. I guess your folks' sense of fun is different than mine. Okay. Okay. How about date of birth? You tell me. Like what? Okay, I'm asked to enter my date of birth. What? As a string. What are some good things to test? Yeah, I know you folks probably think like, were you born BC or AD or something? What was the Roman Empire? What was the Roman emperor when I was born? Hadrian? No. So entering date of birth, like what numbers would I enter for possible? Okay, I'm asking to enter a date of birth though, like as a string, and that's not a number. But I mean, you could enter a negative number, but yeah, you could see something that's not a date, not a recognizably parsable as a date. What's another thing, Connor? Okay, a date prior to Unix times 0. How about something else? You could do a date. You could do a date in the future, and you could do today, right? I'm just out of the oven, or something like that. So what's another class of thing I might enter? Like to test this out. Okay, so you're supposed to take a string that represents a date, and I have to do something with it. So what other things could I do to try it out? Like try it out not badly, to try it out reasonably thoughtfully. Yes. February 29th, or like, yeah, a date that doesn't exist potentially, but also a date that does exist because of leap years. Okay. Okay. How about other ones? Well, something that's not recognized to be a date. Yeah, like a string that's like -1. You know, the string says, "quote my birth date" or something. Yes. Yeah. Okay. Good. So sort of special dates within the year. February 29th is a special one in the sense that with leap years you get certain dates that don't exist during those times. So plausible dates, yes. Jason, yeah. Exactly. Something that's structurally, it sounds plausible. You say, "I'll meet you on December or on November 31st," right? Or on January or on February 30th or something like that. And these things don't exist, right? And the hardest one is like August, September, because there's this anyway. Okay. So those are some good ones. Let's yeah. So often you're looking for these classes of inputs that will clue you into types of mistakes, right? They're handled in similar ways. Misformatted dates, whether you say my birth date or quote my birth date or quote your birth date, where a date is expected, like those are going to be handled in similar ways. They're going to elicit similar behavior. And you look for a representative of things that are handled in similar ways, right? You can't test everything, every misformatted date, so you test some kind of thoughtful representatives of them. Maybe some where December is misspelled or where it's not one of the months. Another is where you have the date number doesn't exist in that month or something like that, right? Dates in the future, today, as Alex famously said. Yeah, so you're looking for things that often lead to same behavior, are handled similarly. If you find a bug with one, probably or it's not handled proper, probably it occurs with others as well. And there's a bunch of sort of heuristics you can use to help yourself suggest ideas here. Do they yield the same event? Do they yield the same error message, etc. Okay. So there's a web form in which the user can enter their integer age. What are some things to test for this? I'm asked to enter my age in years. What things should I test? Okay, negative. Yeah. Negative number. Okay, what's that? Okay, so like a normal age. 10 years old. Okay, a plausible age. What else? Yes, Connor. An implausible age. Yeah. So like I'm 140 or something like that. Yeah, I know. You folks probably think I'm like 900. Yeah, that's right. The oldest person. That's right. Turns out it's not me yet. Okay. So yeah, what other things might I test? So those are some good starts. Yeah. What is that? Double value. Excellent. So someone might say, oh, I'm 2.5 years old. 12.5, and it doesn't take it. Okay. So good. You want to make sure that however it handles those properly. And you don't test it with all double values, but you want to test it with at least one. Yeah. How about others? Yes, Ronan. 0 would be a good one. Yeah, 0 is a thoughtful one. Maybe there's a parent entering this in some form for their child, and child's in their first year, so they say 0. Right? Any others? Yes, Tanner. Sorry? That's a good idea. That's actually a really good idea. Yeah, 9 years old or something like that, right? That's really, really good. Okay, So maybe we'll come back at 4 o'clock, but I want you to think about this one. Suppose there's a web form, and they actually, I'm going to ask, suppose there's a web form where the user can choose from a calendar there, dates for which to search for flights that they want to reserve. So they have a little count, one of those little calendars, and they have to select a date for a flight that as part of the booking process. Think about classes of inputs you might want to check for that. Okay, so see you in arts 206, I think it is, at 4, right? Okay, see you there. Thanks.